On this slide, we have an example of mapping C expression into the corresponding assembly code instructions. And we start with an expression using three variables A, B, and C. And we create those register mappings that we essentially assign certain register to hold the value of A, B, C, and so forth. We may also need to have additional temporary values. So we have more registers dedicated to holding intermediate results of the computation. So then we start with an addition. Apparently this corresponds to A plus 3. And this, of course, is an immediate version of addition using one of the immediate operands. Similar work for subtraction right here. Then once we have these results ready, we can try multiplication. And the final step is to add A, which is mapped to register T0. In summary, we decide which registers we map to the names of our variables and which registers we also need to hold the temporary values of our computation. Finally, these arithmetic operators correspond to the instructions supported by our CPU. The part that is not shown in this fragment is how we load the values into our registers and how we store the result back in memory associated with individual variable. On the next slide, we have a complete example of a program that allocates an array of three integer numbers, adds them together, and stores the result back in this memory. First step in this program is to print this text on the screen, and it's loading register V0 with the value 4, which corresponds to system call for service related to printing strings. And then we print our string on the screen by making this call. Notice that it would be also very advisable to use this alignment directive before we start allocating space for our integer values as required by MIPS hardware architecture. So then we prepare address in register T0 to refer to our input values. The command is load address, and then we load individual integers by load word using offsets 0, 4, and 8, which correspond to the locations of these integers in this array. Next, using these add instructions to do the math. So here we say A0 equals T1 plus T2, and then we say A0 equals again A0 plus T3, and then we save the result back in memory. Our register A0 is already loaded with the required sum, and so we call this operating system service to print it on the screen. I have created a subfolder on my computer where I keep my MIPS programs, and my approach here is typically just create a new text file, then open it in Mars Simulator. Here I simply copied and pasted all the code without any changes. Before testing it, I just clear all the messages and all previous input-output. Then to text or debug, you have to use the assembler, and now we can run it to test how it works. So this prints -69, which is the sum of these three values, as expected. So my only note would be that before allocating this memory to our integers in the data segment, apply the align directive to guarantee that allocation of our integers will be happening on a word boundary.